Hey, 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 welcome on in, guys. We are in the home stretch. How do y'all look so good after like 9,000 cups of coffee and like brains full of content? It's nice. It's nice. Thanks for hanging out with us today. It has been a pleasure being in this room with y'all. A couple quick logistics, and then I'll introduce our next speaker. If you have not had a chance to pick up your Oculus Go yet, they will be distributing those through 5 p.m. on the lower level where the registration area was when you came here yesterday. Also, we hope you will join us after this session. There is a happy hour at 4 p.m. in the lower level where they've been serving the meals. They'll be announcing the hackathon winners, and it'll just be a great chance to celebrate everything else that's been going on today. So here at Facebook, one of our big values is being your authentic self. And our next speaker is very authentic about his love-hate relationship with AI. He loves AI. He spends a lot of time working on it. He also manages capacity at Facebook. So sometimes those things come into conflict. I'll let Bill tell you a little bit more about that and introduce the rest of our awesome panel today. Please give a warm welcome to Bill.
Thank you. Good afternoon, everyone. Welcome to F8, and welcome to F8 ONNX session. I'm very thrilled to be here, top of ONNX, industry-wide efforts started by Facebook, Microsoft, and Amazon back in 2017. And before we get started, a very quick intro today about today's sessions. First, myself, as an intro, my name is Bill Jia. I manage Facebook AI infrastructures, including ONNX efforts. ONNX stands for Open Neural Network Exchange. So whenever we talk about ONNX, we just have to mention neural network. Whenever we talk about neural networks, two things goes to everybody's mind. Number one, quality. When neural network works, it works well. It really works much better than any other AI traditional techniques, especially in the field of machine translation, speech, computer vision, reasoning, and ranking, and many other fields. That's the reason people like neural network. That's also the reason, in the recent years, neural network really gained a lot of popularities. Second thing goes to everybody's mind when we talk about neural network. It's sensitivity. Neural networks have very high quality. When it works, it's great. But however, when anyone changes the structure, the shape, the operations, and the parameters in the neural network, chances are it may not work anymore. Forget the high qualities. And because of this, a lot of people hate neural networks as well. Going back to AI industry, if you look at entire communities, right now across AI industries, with many, many different frameworks and platforms. And the researchers, AI researchers and practitioners, they leverage on one framework to build these awesome neural network models. Everything works, high quality. But whenever he wants to carry this network from one platform into another platform, Jesus, something will get changed because all different platforms, they have different standards, different formats. Then, as mentioned, due to the sensitivity, when things got changed, the neural network, which is very high quality in one framework, may not even work in another framework, which is very lame. As a matter of fact, I would really say, because this sensitivity, because this friction, it really slowed down a lot of innovation, which we should have already achieved in the AI communities. It always reminds me back in the days for the TCP/IP. Back in 1970s, early 1980s, before the born of TCP/IP, and we have many different computer networks. Right? Different networks have different protocols. Then if you want to copy data from one computer to another computer with the same network, great, things were easy. But whenever one wants to copy data from one network to another network with different networking communication protocols, Jesus, the nightmare started. Right? If you can still remember, people use a floppy disk. Jesus, floppy disk. Everybody remember floppy disk? People use floppy disk and hard drive to copy data over. Nightmare. Or if you want to transfer a large amount of data, oh my God, people use something called dinosaur tape to copy data over. It's very hard to use. It takes hours, days, or even weeks to transfer all the data over. At the end of the day, people were very exhausted. Now coming back to AI industry, we're making ONNX we're defining the standards, we're defining the standard formats. We're creating the TCP/IP alike standards for the AI industry. We're going to make the history. And with this, hopefully, all the AI researchers and practitioners, they can create models, train the models, make model work really well in one framework. Then without any friction, he can carry the model to any framework, to any platform he wants to use the model. And the benefits also go to the hardware vendors. And hardware vendors, they can design, they can architecture, they can optimize the hardwares towards the last mile by just focusing on one standard, one format. Okay, without mentioning more about ONNX, let me very quickly go through today's agenda. Following me. So following me, Sarah Birds and Dimitro from Facebook, they will come on stage, talk about history and vision about ONNX. And also technical development work happening at Facebook. Then we're going to have our very close ONNX partners, Bratin Sahar and Eric Boyd from Amazon and Microsoft, talk about ONNX from Amazon and Microsoft perspective. Now, let's welcome Sarah Birds, technical program manager at Facebook, talk about the history and vision of ONNX.
Thanks, Bill. I know that we've been talking a lot about ONNX today, and you had to wait until the last session to hear more about it, but let's get into it now. So a year ago, the AI industry was extremely fragmented. We had many different companies working on different frameworks, different tools, different backends, different hardware libraries. And the challenge is that unfortunately, each of these tools needed to talk to every other one, which meant we had a terrible spaghetti mess of converters that were fragile, difficult to maintain, and just frankly difficult to use. So the idea with ONNX was, let's see if we can have, start with a simple idea, which is maybe there's one language that we can use for all tools to communicate so that we don't have to have a converter for every tool combination. And so the vision of ONNX really is that simple. Its tools should work together. We want to focus on developing great AI and not fighting our tools. So we got together as an industry to look at how do we really make tools work together? How do we make a great developer experience where you can use the tools that are right for you? And so with ONNX, we looked into it, and the best starting place was an intermediate serialization format that made it possible for models to go from where they were developed, the framework that they were developed and trained in, and then transferred to another framework for inference. And so, or another framework or hardware library or backend. And so that's what we designed ONNX to do. It works with many different frameworks. You can export your model in ONNX, and then you can take it to whatever backend hardware library framework that you want to use for inference. So if we look at, what is ONNX actually? ONNX is a way to represent our neural networks as a graph with operator specifications and a serialization format for the weights, so we can transfer the trained weights. And this sounds pretty simple, but a lot of the work is actually happening in the operator specs. We need to make sure that the operators are available on all the different tools and that they mean the same thing in each framework, in each tool. So a lot of the effort that we're doing together with all of our partners is making sure that our tools all understand these same operator formats. And the nice thing about the ONNX design is it actually lets us achieve two different goals. First, as I talked about, it allows us to serialize models between frameworks. So you can do things like develop in whatever framework is most flexible or expressive for your model, and then deploy in the one that's going to work best in your production system. The other advantage is that this provides a common target for optimization in different backends. So rather than, if you have a new optimization technique, rather than having to go and implement it for every different model format, if you do it for ONNX models, then it will work in any tool that supports ONNX models. And so we're really excited about this because now we can focus a lot more on doing great optimization and less on putting it in every single tool. This also enables people, researchers and academias and startups, to more easily participate because now there's one format that can reach many different developers. So I think you've heard a lot today that we believe AI should be open. We wanted ONNX to be a project owned by the community because it's too important for any single organization to develop alone. We wanted it to be framework agnostic and be useful in any tool or framework. And we felt that we needed the input and the feedback and the collective expertise of the many different people in the field. And so with ONNX, we open sourced it early on. If you've been following the project, we put it out there when it was closer to an idea than an implementation. And the idea was that we were going to develop this together with the community. And that we hope that with ONNX, by doing this, we can achieve something better together. And so that's what makes ONNX really different in our mind. Obviously, there's many different standards efforts out there, but with ONNX, we started by focusing on partners and community and making sure that we were doing this together rather than focusing on the particular design. AI is moving very quickly, and to keep up with the speed of innovation in the field, we also wanted to make sure that ONNX was more of a living language that we could easily adapt and evolve rapidly to meet the changing needs of AI, because a language that can't transfer the latest models isn't useful. So with ONNX, it's more about the partnership in the community agreeing to keep all of our frameworks speaking the same language than having a rigid standard. So with ONNX, we're very fortunate to have now 15 companies part of the effort and many others involved and participating all the time. We also have many people in the community involved in the effort. And all of these companies are committed to helping make tools interoperate and support the ONNX vision. Let's see. So I'm also very excited to announce today that Baidu is joining the ONNX effort, and they will have Paddle support for ONNX support in Paddle available at the end of May. And also Qualcomm currently has ONNX support in their snappy hardware runtime, so you can go and use that today. So the goal of ONNX is to support all AI applications. No matter what your model is, we're hoping that we can transfer it with ONNX over time, and we're working towards that. However, we had to start somewhere, and so we started with vision applications. So ONNX is currently in version 1.1, I think, 2. And basically, it should work for all of your vision applications. And we've also been doing a lot of work on NLP that Dima's going to tell you more about. But it should work, so you can start trying it for NLP. This is a fast-moving project, though, so we hope to support more things soon. So if this isn't what you're looking for yet, do check back soon. We also are working on a model zoo that is that will be expanding over time, so you can easily find great pre-trained models. Everything from your standard benchmark to the latest research from FAIR and other great research institutions. And they'll run on any framework or hardware that supports ONNX. So we hope that you'll use them and maybe even contribute some of your own. And with that, I'd like to introduce Dimitro, who is our tech lead and engineering manager for ONNX, to tell you more about what we're doing specifically with ONNX at Facebook.
Thank you, Sarah. I lead engineering efforts on ONNX at Facebook, and I'm going to talk about our journey with ONNX and how we use it in different products. At Facebook, we use deep learning in a lot of our products to power all the exciting experience which you've been hearing throughout the day today. And we constantly do research to innovate on new models and new approaches and make our products better. As we do that, we strive to bring those innovations into production as fast as possible, so we can make products better and delight our users. And we do that whether those models run in the data center on a massive scale, or whether they're running in your pocket on a mobile device. At Facebook, we always believe in building engineering tools which solve the issue at hand. Thus, by the end of last year, by the middle of the last year, we basically ended up with two mostly independent deep learning tool chains. PyTorch, with its focus on fast prototyping, which is really suitable for research, and Cafe 2 with its uncompromised performance and really awesome scaling capabilities, as well as ability to run on mobile devices. And this setup allowed us to iterate on both tool chains really quickly. However, it was sometimes not very convenient for client teams, because it might take several weeks to basically take model from one stack and port it to another one. As we reached out to other kind of industry partners who also been running into similar problems, we decided to explicitly invest into interoperability vision, and that's basically how ONNX was born. As you heard earlier today in Shrep's keynote, we are taking even further steps to share components between Cafe 2 and PyTorch deploying frameworks, and basically merging them into a single offering from end-user perspective. ONNX is a native model representation of PyTorch 1.0 framework, which basically means that you can take a PyTorch model and transfer it to another tool or use it with another frameworks, as well as ONNX is a preferred interface for integrating with hardware-accelerated libraries. What does it mean in details? On front-end side, we use ONNX as a standard serializable representation for models, both when talking within PyTorch itself, and also if developers want to take that model and utilize some other tool or different framework to use it. One of the strengths of PyTorch from the early on was so-called defined by run execution. Basically, your model structure is embedded directly in the host language in Python. And it comes with a lot of useful benefits, especially for prototyping. Because you can use all the language's features, for example, the favorite debugging tool of all times, the print statement, still works. So thus, the big focus of ONNX work for PyTorch is basically developing tools for extracting serializable model architecture from the host program from Python. So it can be represented as a well-defined ONNX graph and can be targeting scalable deployment or can be transferred to different tools. On backend side, getting ultimate performance from the deep learning solution often comes down to utilizing the best available libraries, which are often built by hardware vendors for their platforms. Such libraries can utilize hardware magic and really make your AI models run really, really fast and scale better. But as number of different chips and hardware combination growing, it becomes pretty tedious to integrate all of them in deep learning solutions. That's why in Cafe 2 and PyTorch, we basically utilize ONNX as a lingua franca to talk to different hardware backends and basically interface with libraries built by our hardware partners. Common pattern is that when tasked with running particular AI model at scale, we will basically identify a part of computation, like part of the graph, which is suitable to run on particular accelerated hardware, and basically use ONNX interface to transfer this computation and run seamlessly the entire model end-to-end as a part of the same network. Deep learning advances pretty quickly, and we are actively participating in pushing forward the ONNX specification and developing related tools to keep up with that. I want to mention one example of developing the spec. In a lot of cutting-edge models, especially around natural language processing, new research shows that they exhibit more of dynamic behavior. In other words, your models start to resemble more of like traditional programs with control flow and data dependencies in control flow and stuff like that. Thus, together with our partners, we basically developed extension to the ONNX spec to represent control flow structures and tailored it specifically for neural network needs. Apart from improving the spec itself and also adding support for it in PyTorch 1.0, we at Facebook collaborate with ONNX community and other partners to develop tools and integrations to enable all developers to benefit from the cutting-edge AI technologies. Among many others, I want to highlight two of them to you today. I'm really excited that new version of NVIDIA Tensor T4 inference engine, which was actually announced last month at GTC in the same conference center, comes with native ONNX support, which basically means that you can take your computation or part of the subgraph execution, which I mentioned earlier, and run it directly through ONNX interface on Tensor T platform. We worked very closely with our friends at NVIDIA to co-develop the comprehensive support of ONNX there in Tensor T, and I'm very excited that that connection is actually open sourced as of today and available publicly. Similarly, I'm very excited to announce that ONNX CoreML support is now production ready and is available online also open source. It basically brings accelerated neural network support through ONNX interface to iOS ecosystem. And it was a joint co-development between Apple, Facebook, Prisma, and other community partners within ONNX community. At last, while ONNX project is itself pretty young, we've seen many products within Facebook benefit from the vision of interoperability which it brings. The common pattern which we are seeing is it allows us to bring innovation from research environment to production and scale faster. And today I want to highlight 3 examples of that happening in real products. As you probably heard earlier today in Shrep's keynote, Oculus Research is working really hard to bring natural-looking avatars to virtual reality. And it's probably just easier to make one of them speak for itself.
At Oculus, we utilized ONNX to streamline the delivery of an audio-to-animation model for lip sync. Built and trained in PyTorch, ONNX allowed us to rapidly move the model into production with Caffe 2. This model now drives lip movements in the new Spaces avatars and is also available to all Oculus SDK users.
Okay. Another example of product applications is optical character recognition system, which allows us to extract textual information from a lot of images and videos, which gets uploaded to Facebook and contain embedded text in them. Such system powers product experiences such as accessibility or photo search, for example. The OCR process was recently improved by applying novel neural network-based techniques, both for recognition and segmentation of the image. And actually, ONNX allowed the team to quickly prototype and deploy the model to production. And now it powers a lot of OCR experiences across many languages and font types. Also, machine translation is an important use case of deep learning at Facebook. Our neural network-based translation system powers more than 2,000 language pairs and serves several billions of translations per day. And we strive to constantly innovate in translation quality and basically iterate on model architectures to ship the improvements to our users and deliver better experiences like highlighted here. Actually, last year, Facebook AI Research Group published state-of-the-art paper on using convolutional neural networks, which are usually used for vision applications, to machine translation tasks, and had their implementation in PyTorch. The teams basically utilized ONNX and control flow functionality, which I mentioned earlier, to speed up deployment of this model to production, and right now it powers some of the translation directions in Facebook product. And in particular, such approach allowed us to share a lot of code base between research and production environments without slowing down either. To sum up, we are working really hard to push forward ONNX vision of interoperable tools. ONNX ecosystem allows us to streamline research to production transfer and ultimately allows us to utilize the best technologies for efficient and scalable deployment applications, whether they're running in data center or on the mobile device. Thank you.
Thank you. Thank you, Sarah. Thank you, Dimitro. That T-shirt, I really like the T-shirt. That ONNX T-shirt. Okay, now it's my high honor to welcome Breton Sahar, the Vice President and General Manager from Amazon Machine Learning Platform Group, to talk about ONNX from Amazon's perspective. Thank you.
Thank you, Bill. Great. Thank you, Bill. So let me start by talking about how we look at machine learning at Amazon. And so what I have here is the machine learning stack at AWS. And we start with the lowest layer, which is where we look at engines. And our goal is to make sure that AWS provides the best platform for all frameworks. That includes TensorFlow, it includes MXNet, it includes PyTorch. We have support for Caffe, we have support for Chainer, and so on. So we want to make sure that whichever framework you want to use, we actually provide you the best platform for that. Now, sitting on top of the engine layer is our managed service, SageMaker. We introduced it last year at reInvent, and it provides an entire managed service starting with notebooks, and then training, and then hosting. And it really takes away most of the undifferentiated heavy lifting, so that as machine learning developers, you really can focus on developing the models and on the differentiated work. So it supports distributed training. You just go in and talk about the instances you want, and it takes care of all the stuff underneath. It does auto scaling. It does A/B testing. So you can have endpoints, and you can say, 80% of this goes to one endpoint, and 20% of the inferences go to the other endpoints, and so on. And we will be adding a lot more features to it as it goes on. So I would love to hear feedback about it, and I would love to see people use it and tell us how we can make it better. And then on top of that are our API services. These are the services that we provide so that app developers can actually use AI into their applications. And we broadly look at them as imaging or vision applications. So that's where we have recognition. And then a set of speech applications. We have transcribe, which is a speech to text. And then translate, which is really translating between languages. We have Poly, which is a text to speech, which is actually the voice of Alexa. And then comprehend and Lex. Comprehend is getting meaning out of documents, and then Lex. And of course, we also look upon not just deep learning in the cloud, but deep learning at the edge as well. And that is where we have AWS Deep Lens, which is the camera that we have that you can use to download deep learning models. You can train them in SageMaker and then download them onto Deep Lens. Now, as part of this machine learning stack, we have been looking at adding support for ONNX, because we truly believe that having a framework-agnostic intermediate language helps the community exchange models between frameworks, and that's good for everyone. So as part of that, ONNX integration is part of Apache MXNet, and AWS has been supporting both the import as well as the export. The import of models from MXNet has already been completed, and we should shortly be doing the export and releasing it out in the open source. We also have a model server that now supports ONNX, so you can actually write models in your favorite framework and then translate them to ONNX, and a model server would be able to host those models. And we also support the ONNX Model Zoo. So we truly believe in this vision and about having a framework-agnostic intermediate format that we can use for efficiently supporting various frameworks. And then, of course, going forward, we are working closely and will continue to work closely to see how we can add more ONNX support into the other parts of our machine learning stack. With that, I'll hand it over to Bill.
Thank you, Bretton. Thank you, Bretton. It's so exciting to say so many works for ONNX coming from Amazon. Now, it's also my high honor to introduce Eric Boyd, the Vice President from Microsoft AI Platform Group, top at ONNX from Microsoft perspective. Thank you, Eric.
Thank you, and thank you for having me here. I know you guys have been through quite a long couple of days, and I think I'm the last thing standing between you and alcohol, so we'll try and make this as focused as we can. I want to talk a little bit about the journey that Microsoft went through and how we came to ONNX. Deep learning and machine learning at Microsoft really evolved in many of our different teams, the Bing Relevance team, the Bing Ads team, our speech services, our vision services, all the different pieces of Microsoft. And as they evolved, it was fairly organic. There weren't, different teams worked in different areas. And we found ourselves in a situation very similar to what Facebook described of having all these teams and now needing to optimize for all of the different hardware layers. As you look at the different GPU frameworks, as you look at CPUs, we've done some really interesting things with FPGAs, but needing to optimize each framework for each of those or exchange models between them was really cumbersome. And so we worked very closely with Facebook and Amazon as well, and ONNX has really provided a really great model for us to exchange things and really simplified a lot of the work that we've done. And so we've really bought into this approach and built it into basically all of the layers of the stack as we think through things. And as you look at the Microsoft sort of AI platform stack and how we put everything together, at the top level, you have things like cognitive services, vision APIs, speech APIs, where people can just go at and call these direct models. The next layer is Azure Machine Learning, where you can work to build and train your models in the cloud and output those as ONNX models. Additionally, is Visual Studio Tools for AI, a development framework, which again makes it very easy to create and produce ONNX models. The next layer down is the Azure infrastructure, where we have all the different compute frameworks that you may need, and all of those specifically optimized to run well on ONNX models. And then at the bottom, you have all the different devices that you may need. And we've even put into Windows ML, which is an ONNX-capable runtime in the operating system. And so as of I think it's the April release of Windows, everyone on their device will have ONNX support directly into it. And developers won't have to add any extra libraries or anything. They will just run and take your libraries, and they'll just go straight from there. So it's been really core to how we think about this because, and I feel like Facebook keeps stealing our line, but we're really focused on AI needs to be open. And we've worked really well because they seem to also believe that a lot. And so it's great that we have such good alignment on that. But having AI in the open has really accelerated. AI is going to transform every business out there, and being able to do it in the open is really just accelerating it. So we very much believe in that. I wanted to take a little bit of time just to talk through one of the tools and how that works with ONNX. And so if I talk about Visual Studio Tools for AI, Visual Studio Tools for a data scientist is a good place where you can start to edit and test your training scripts. The first steps of defining the model and going through all the steps that you may need to do to build it and refine it, and what are the different layers I need. And then right from there, you can submit your jobs to train locally or to train in the cloud. Very simple, easy to use interface, very extensible. And then you can view the job performance. I've trained 100 different models. Which was the one, which hyperparameter tuning actually worked the best? How do I sort of remember and keep track of all the different things? And then, it typically gets handed over to the developer who's going to take this and now needs to figure out how to deploy this into an application. And so very simple interface to convert the models into ONNX. And then from there, very simple model to take all of the ONNX models that you've generated and deploy them onto really any platform that you need to. Anything from your mobile devices, iOS and Android, to all of the Windows devices, to custom IoT devices, to clouds, to anywhere that you need to go. We've really focused on making that simple. And this again is a plugin. It's available. You can go get it. Azure.ai, and you can find all the plugins and tools that we have. So ONNX has really been very important to how we've thought about the AI journey and where we're going with it. Has dramatically simplified things internally for our first-party applications, and we're really excited to be bringing that to our third-party applications as well, and really excited to be partnering with the industry. The industry coming together just really accelerates this whole thing. So thank you for that. Bill?
Thank you, Eric. Thank you, Eric. And that's really great to see the passion from Eric. I feel like in terms of passion to ONNX, we too, and maybe Brettin as well, we have some competition over there. Okay, and also I want to thank you, Brettin, and Dimitri and Sarah for all the great works they have drive at Facebook, at Microsoft, and Amazon. Before we end these sessions, I want to re-emphasize, so ONNX, even though ONNX started by Facebook, by Microsoft, by Amazon back in 2017, that's really a community project. And we welcome all the participants, all the people contribute to these projects. And we have the GitHub repositories. We welcome everybody to check it out and contribute. And also get involved and use ONNX and experiment your neural network models using ONNX. And follow us. We have a lot of news published. We pushed a lot of news into Twitter page and Facebook page. And follow us and get the latest news about ONNX. Obviously, we have done a lot with ONNX. You have heard a lot of fantastic news, all the progress coming from Facebook, coming from Microsoft, coming from Amazon. But really say ONNX is a very long journey. We've just done 1% of the entire journey. There's still a lot of work we need to finish, we need to accomplish to make sure all the AI researchers and the practitioners for all the different models we want to build in one framework, they can carry it over to all other platforms and frameworks. And by doing that, we can really accelerate the innovation of AI industry. And ONNX can reshape the entire AI industries. To finish my talk, these sessions with a high note, I want to play a video. In this video, you can see all the evolution and revolution for the entire AI stuff happening in the industry. And also you can experience how and why ONNX can transform and can reshape the entire AI industries across all different AI platforms.
How does the brain work? What is intelligence? That's really a big scientific and technological question that a lot of people are fascinated by. In the 30s, people realized that you could sort of mechanize logic. This was, classic work of Alan Turing, for example. And then in the 40s, people started realizing that they could reduce thought to a series of simple operations, and they started making the parallel with the brain. The phrase artificial intelligence was coined in 1956. The current AI systems that are capable of learning are inspired by the brain the same way airplanes are inspired by birds. The bird is an existence proof of the possibility of heavier than air flight, and the brain is an existence proof that an intelligent entity can learn from interacting with the world.
AI has the ability to change life for each and every individual in the world.
There's a lot of excitement around how can we personalize applications to make smarter decisions for people.
We're going to have better image recognition, speech recognition, better systems for medical diagnosis. We're going to have cars that drive themselves. The number of traffic accidents will go down. AI will save lives. That's kind of a good motivation to work on it.
A lot of the problems are very complex, and without a rich data set, it's difficult for the algorithms to learn. What's changed over the last couple of years is cloud computing has made it possible for anyone to run large jobs and have enormous compute power available at any time. AI is moving so quickly. We're having research breakthroughs every day, and we want to get those research breakthroughs into the hands of people as quickly as possible. With ONNX, we're trying to create a world where more of the AI tools work together.
ONNX provides a common language by which we can exchange models that we've learned from data. Imagine you're in a group of children and there's Lego, there's Duplo. They typically don't fit with each other, so you can't really play with each other. But if you design the interface pieces, then all of a sudden you can play in a group. It actually accelerates the speed by which we make progress in areas of AI.
You don't want systems that have to be re-engineered each time. Platforms like ONNX allow us to build on each other's success.
Open source frameworks like this help everyone in the community make progress in AI because we don't have a monopoly on good ideas. And everybody knows they don't have a monopoly on good ideas.
Research is always about the research community. Every invention is ultimately the work of many people feeding into it.
The famous physicist Richard Feynman said that you don't understand something until you build it yourself. If you build an intelligent system, you understand more about human nature.
I think it will work with us. It will be of us. We have to put our better selves into the AI. And if we do that, we're all set.
Okay. Thank you very much.
All right, everyone, that is it for Grand Ballroom B. If I can make one plug, I work usually on the Facebook analytics team, and we still have a few pairs of free socks at the analytics booth if you want to go to the back of the festival hall. As a reminder, you can pick up your Oculus Go's in the registration area on the lower level, and I hope we'll see you at happy hour at 4 p.m. in the lower level as well. Let's keep building together. Thank you, F8.